all to video lecture of Dinesh Tyagi classes. In this video lecture, we will cover matrices and its operations. So first of all, I define what is the meaning of the term matrix. Matrix is a special kind of arrangement of numbers. Of course, a special arrangement. So if I define matrix, matrix is rectangular arrangement of numbers, and numbers may be real or complex. For example, if I write these four numbers are in a special arrangement. They are kept within a bracket and this is denoted by capital letter. So this is a matrix. This contains four elements 1, 2, 3 and 4 and they are arranged in rectangular shape. Here if I say these horizontal lines are called rows, this is called row 1 and this is called row 2. These vertical lines are called columns and this is called column 1, this is called column 2. So in short, if I define matrix, then matrix is a rectangular arrangement of numbers, may be real or complex, and in matrix horizontal lines are known as rows and vertical lines are known as columns. Then very important word comes into effect, that is called order of matrix. Order of matrix is defined by rows and columns. Rows and columns. If we talk about this matrix, then how many rows are here? 1, 2, so 2 rows, and how many columns? 1 and 1, 2. So order of this matrix is 2 by 2. This order tells us the shape and the size of the matrix. If I multiply these two, then it will give you 4, and this 4 is nothing but number of elements in the matrix. So if you know the matrix, then you can easily know how many rows are there, how many columns are there, and you can easily know how many number of elements are there in the matrix. If we take another example, then if I take matrix B like 1, 2, 3, 0, 1 and minus 2, then of course how many rows are here? 1, 2, 2 rows, and how many columns? 1, 2, 3, 3 columns. So this is a matrix of order 2 by 3 and it contains 6 elements. So if I take another example like 1, 0, 1, 3, 4, 2, 1, 0 and 5. So this matrix is of order 3 by 3. If I talk about this element, then this element is lying in first row and first column, then its position is 1, 1. This element is lying in first row and second column, so its position is 1, 2. This position is 1, 3, 2, 1, 2, 2, 2, 3 and so on. So if I want to write a matrix in terms of positions, then I can write 1, 1. This element will be 1, 2, 1, 3, 2, 1, 2, 2, 2, 3, 3, 1, 3, 2 and 3, 3. So this is a matrix of order 3 by 3 in terms of positions. So this is a matrix of order 3 by 3. In general, if we denote a matrix, then matrix is denoted in this way. This is general element and this is the order of matrix. So Aij is what? Aij is the element in ith row and jth column. Sometimes a question generally asked in board examination in which they ask from a matrix of order 2 by 3 in which general element is defined as Aij equals to I plus j for all I and j. So in this question I have to form a matrix of order 2 by 3. So if I write matrix of order 2 by 3 in terms of positions, then I can write 1 1, 1 2, 1 3, 2 1, 2 2, 2 3. So this is a matrix of order 2 by 3. Now question arises, what is 1 1, 1 2, 1 3, 2 1, 2 2 and 2 3? For finding out these positions or these elements, I will use this definition. So if I need 1 1, then in this definition I will put I equals to 1 and j equals to 1. This is 1 plus 1, it will give you 2. If I write a12, then of course 1 plus 2 will give you 3. If I write a13, then it will give you 4. Similarly, a21 will give you 2 plus 1, 3. If I write a22, then it will give you 2 plus 2, 4. If I write 23, it will give you 2 plus 3, that is 5. Now, matrix A is what? So, matrix is 2, 3, 4, 3, 4 and 5. So, such kind of question may be asked in board examinations for 1 mark only. Now, the next topic is types of matrices. Types of matrices. So first matrix is called row matrix. What are row matrices? Row matrices are the matrices in which matrix contains only one row. For example, if I say A equals to 1, 2 and 3, then this matrix is of order 1 by 3. Since it is containing only one row, then that is why it is called row matrix. Second is called column matrix. Column matrix. In this matrix, number of columns are 1 only. For example, if I write 1 2 3, then how many rows? 1 2 3 and only one column. So due to this number of column, because number of column is 1, this matrix is called column matrix. Third and the important thing is square matrix. A square matrix, as the name indicating square. A square matrix is a matrix in which number of rows are equals to number of columns. For example, if I write A, this is 1, 2, 3, 4, then this is a matrix of order 2 by 2. And in other words, I can also say that this is a square matrix of order 2. If I using word square, then it's enough to say it is a matrix of order 2. Otherwise, we can say this is a matrix of order 2 by 2. If I take another example of order 3 by 3, then we can say 1, 0, 1, 2, 1, 3, 3, 1, 4. This is a matrix of order 3 by 3. Of course, this is also a square matrix. Now, if you look at this position and this position, these three positions are very special positions. This position is 1, 1 and this position is called diagonal position. 1, 1, 2, 2, 3, 3. All these three positions, all these three elements are called diagonal positions and diagonal elements. And the line which joins them is called main diagonal. So this is called main diagonal. And positions like 1, 1, 2, 2, 3, 3, all these positions are called diagonal positions or diagonal elements. Diagonal elements. So these positions are known as diagonal positions and line which join them is called main diagonal. Next matrix is called diagonal matrix. Diagonal matrix. This matrix has to be a square. So if I define diagonal matrix, then diagonal matrix is a square matrix in which all positions which are other than diagonal are 0 and main diagonal positions are non-zero, then this matrix is called diagonal matrix, and this matrix can also be written in this form 1 2 3. This is called diagonal matrix 1 2 3, in which first element is representing 1 1 position, this is representing 2 2 position, and this is representing 3 3 position. After this, after diagonal position, another matrix comes that is called scalar matrix. Scalar matrix is a special kind of diagonal matrix. In this matrix, all main diagonal positions are equal. If I write like this, then this matrix is a scalar matrix. Of course, this is diagonal as well as scalar. Sixth is very important. It called unit matrix, or we say identity matrix. Identity matrix. Identity matrix is a square matrix, of course, but main diagonal positions are 1 and all other elements are 0. This is denoted by I. This is matrix of order 2 by 2 and it is denoted by I2. So I2 is a identity matrix of order 2 by 2. It is 1 0 0 1. Another example of order 3 by 3 is 1 0 0 0 1 0 0 0 1. This is called I3. Now, last matrix is 0 matrix. As the name indicating 0 matrix, this is a matrix which is having all elements as 0, like this 0 0 0 and 0, and it is denoted by this. What is the beauty of 0 matrix? This matrix may be a square matrix or may not be. So 0 matrix may be of order 2 by 3, 0 0 0 0 0 and 0. This is also 0 matrix. Now we will discuss equality of two matrices. If I have two matrices, say A and B, this is matrix A of order m by n, and another matrix I have B of order p by q. Then on what grounds, on what conditions we'll say these two are equal? So we can say matrix A and B are equal if number one, number of rows in first matrix is equals to number of rows in second matrix. That means M equals to P. Second, if number of columns in first equals to number of columns second, that means N equals to Q. If rows are equal, columns are equal, then obviously I can say orders of A and B are equal. So this is first demand of equality of matrices. If two matrices are there of same order, then they may be equal. Why I am saying may be equal? Because of there is another condition on which equality depends, and that is if Aij is equals to Bij for all I and j. If all three conditions exist simultaneously, then you say matrices are equal. And what is this? This is called corresponding elements of both matrix should be equal. What is the meaning of this condition? That means 1 1 position of this matrix should be equals to 1 1 of this, 1 2 position of this matrix should be equals to 1 2 of this, 1 3 1 3 2 1 2 1, means all corresponding positions should be equal. So sometimes question may be asked on this concept. I take one example. So question is, find the value of A and B such that this is A plus B, this is 5, this is 2, this is AB, and there is 6, 5 2 and 8. There are two matrices which are of course given equal, and they are asking about values of A and B. So if you look at these two matrices, they are of same order, of course 2 by 2. If we look at 1 2 position, then 1 2 positions are same, 2 1 positions are same, but according to equality of matrices, 1 1 position of this matrix should be equal to 1 of this, and 2 2 position of this matrix should be equal to 2 2 position of this matrix. So we can equate corresponding elements on equating corresponding elements, then it will give you A plus B equals to 6 and A into B equals to 8. So you have two conditions and two unknowns, so you can easily solve both the equations. So if I say it's 1, it's 2, you just solve it from 1 and 2. So I am putting value of B from 1, and value of B from here will come 6 minus A, that is equals to 8. 6A minus A square equals to 8. You can make equation A square minus 6A plus 8 equals to 0. If you factorize it, then it will give you A minus 4 and A minus 2. So from here we can say A is 2 or 4. Now if you look at equation 2, product of A and B is 8. So if A is 2, then equation 2 says B is 4. If we take A equals to 4, then value of B from equation 2 comes 2. So this is the possibility of values of A and B: A2, B4, A4, B2. Now we will discuss next topic called operations on matrices. So next topic is operation on matrices, and first topic out of operations is addition, how we add two matrices. First of all, we have two matrices of order m by n and p by q. If these two orders are different, then we cannot add matrices. So if you want to add matrices, then both the matrices should be of same order, m by n and m by n. If I define some of these two matrices and we denote it by A plus B, so A plus B is defined as a matrix of same order as of A and B. So A plus B is also a matrix of order m by n. Then journal element of A plus B is denoted by Bij. That means 1 1 position of A plus B will be A11 plus B11. That means you have to add corresponding positions. For example, if we have A equals to 1 2 3 4 and B is 3 1 0 and minus 1, and if you want to add A and B, then of course both the matrix of order 2 by 2, so we can add them. If I am adding A and B, then corresponding elements will be added. So 1 plus 3 will come here, 2 plus 1 will come here, 3 plus 0 will come here, and 4 and minus. So it will give you 4 3 3 and 3. This is how we add two matrices. It's very simple. Just add corresponding positions 2 1 3 0 4 and minus 1. It will give you a matrix of same order, and here A plus B is 4 3 3 3. Next is called subtraction of two matrices. Once again, if we want to subtract two matrices, then matrix should be of same order. If I am taking A, matrix of order m by n, and it is denoted by Aij, this is Bij, and of course of same order, then difference of A and B is denoted by A minus B or B minus A. If I want to find A minus B, then it's similar as we find their sum. So A minus B is again a matrix of same order, but its corresponding element is Aij minus Bij. That means corresponding elements are subtracted. So if I take any example in support of this definition or this concept, if A is 1 2 3 4 and B is 3 1 2 and 4, then A minus B will give you, so you just subtract corresponding positions. 1 minus 3, you write 1 minus 3, 2 minus 1, 3 minus 2, 4 minus 4. So it's minus 2, 1, 1 and 4. Now question arises, if I find b minus a as well, then will it be equal to a minus b or not? So I am trying to find b minus a and will check whether a minus b equals to b minus a. If I find b minus a, then of course 3 minus 1, 1 minus 2, 2 minus 3 and 4 minus 4. If you simplify it, then it will give you 2 minus 1 and 0. Now look at a minus b, that is here, and b minus a. Are they equal? Of course not. Because of, if you look at one position, minus 2 and 2, 1 minus 1, 1 minus 1, 4 and 0. Each and every position is different. So we can say a minus b is not equals to b minus a. So always keep in mind, subtraction is not commutative in nature. And of course, if we talk about sum a plus b, then a plus b is equals to b plus a. Sum is commutative as it was in case of real numbers. Why I am using word real numbers? Because of matrices are formed by using real numbers. So addition is as commutative in real numbers, so it is commutative in terms of matrices also. So matrix addition is commutative, but matrix subtraction is not commutative as in real numbers. So next operation on matrices is scalar multiplication. What is the meaning of scalar multiplication? In this operation, we will try to multiply a constant with the matrix. For example, A is a matrix of order m by n and k is any constant. If I multiply constant into matrix, then outcome is also a matrix of same order, of course. What is general element of this matrix? That will be nothing but k times general element of the original matrix A. For example, if A is 1, 2, 3, 4, so this is a matrix of order 2 by 2. If I say find 2A, then 2A is what? You will multiply 2 in each and every element of A. That means 2 into 1 is 2, it's 4, 6 and 8. So it's very easy, just multiply each and every element of matrix A. If I take another example and I say, if A is matrix called 1, 2, 3 and 0 and B is 3, 1, 1, 2 and I say find 3A minus 2B. Then if you look at this question, then 3A is of course a matrix thrice of A, 2B is again a matrix twice of B, and then subtraction. You know very well matrix minus matrix is matrix. So 3A minus 2B will come matrix. Now in order to find 3A minus 2B, I need to find 3A first and 2B. 3A means thrice of this. So it's 3, 6, 9 and 0. If I find 2B, then it is twice of B and it will be 6, 2, 2 and 4. 6, 2, 2 and 4. And if I find 3A minus 2B, then of course you can subtract these two matrices which are of same order. So it's 3 minus 6, 6 minus 2, 9 minus 2, 0 minus 4. So it is minus 3, it's 7, it's 4, it's minus 4. So this is the concept of scalar multiplication.